Good afternoon, everyone. I hope you had a nice lunch and coffee, and now your concentration is a bit in the mean, but I will try to a bit wake you up and talk about my journey with the Oracle Database 21 sharding feature, which I started as kind of evaluating this technology for a potential client of mine in Canada. It's a startup company basically that does a lot of software for the airlines, and somewhere down the road, the requirement from this particular company was that we need to make sure that the data does not leave particular country or even particular like state in Canada or in US. And naturally, sharding comes in place because our solution was based in Apex. Now, before we begin into details, I will skip this slide because there is a lot to talk about the sharding itself, and I have a lot of hands-on demo to show you, so probably you can read afterwards who am I and what do I do. It's just that I'm also an Oracle guy, 20 years with pretty much every Oracle release, and out of which the last 5 years I spent significant amount into DevOps world, so Kubernetes, containers, Podman, Jenkins automation and stuff. Now, what's the agenda for today? Very quickly, we're going to talk about general what is sharding, what is the architecture, what are the sharding database schema objects, what are the, let's say, basic sharding methods, how we can query a sharded database, few examples about that. Then we're going to talk about one undocumented feature about how to access a DDL for particular shards, and where you can test the Oracle sharding, because as of now, if you really want to test like from a home lab perspective or even product evaluation, it's quite difficult to test sharding. You'll see later why. And just recently, like 2 weeks ago, while I was on vacation, I got my Oracle 23c beta access, and I got access to Oracle sharding, so my vacation was done, Oracle 23 sharding. And I am still under, sorry? And I'm still under impression because, you know, this is a game change, and we'll see later why this is the case. And then my demo is like how we're going to migrate a application written in a mean stack that has MongoDB as a backend, sharded replica set in Mongo, to Oracle sharded database 21c, like Python hands-on plus Apex to visualize the data. And then there are some more details about Oracle sharding with regards to how you can learn sharding from the Oracle labs, from which specific, let's say, sources of information. And very important, I'm giving you 4 extra contents, and those are kind of slides about the Raft, which is the new sharding, let's say, technology, which I'm going to present shortly, and how to deploy Oracle 21c sharded database in containers, because believe me, I spent 2 weeks and countless hours of, let's say, trying to enable this to run in a Docker container. Half of the Oracle helped me, so thank you, Paolo, for actually connecting me to half of the Oracle. And then there were a couple of, let's say, errors and lessons learned, which I'm also sharing with you, so you don't have to go through that. And the last thing is also extra content about storing JSON data into a sharded database. The official documentation that is online is actually misleading. It's wrong. It's not working. You're going to get gazillions of ORA 7445 errors. And I can show you now how this is worked, but I'm not going to present this because we don't have the time for that. So, but before we begin, Vlatko, I want to thank you as well, because you actually were part of this, and at very last point you decided to, from personal reasons, to step back. So you are pretty much aware of this content, and this could not be possible without you, so thank you for that. And off we go. So what is sharding, and actually why do we need sharding? So in most basic English lame terms, sharding is a technology which allows us to split a particular subset of a data and to store it on a different database. Whether this is co-located on the same machine or on a different, of course, doesn't make sense to be on the same machine, but it's a technology to split the data, like slice it and dice it. Now, before Oracle sharding, we could not grow, we could not scale horizontally. We were always scaling vertically, right? So we were adding more CPU memory if you have extra data, backspine switches and all stuff. But all the data was in the same data center, right? So outages, yeah, you can prevent with data guard, Golden Gate and stuff. But I always want to scale out horizontally, like, you know, the NoSQL databases. And because, you know, the ACID model and the hard referential integrity between the schemas, this was not simply possible. Yes, you can scale with Golden Gate, active. Good luck with that. I got my white hair, sorry, because of that, but nevertheless. But now sharding is actually changing the game, in a sense that Now, with sharding, we can actually have the power of NoSQL databases, and we can scale in and scale out our data quite easily, literally on a command line. We can geographically distribute the data based on particular, let's say, regulations like GDPR or PIPEDA in Canada or protection set in USA, and you name it. It has to be elastic. Elastic means that we don't have to spend weeks in creating new environment. I have to have a click and spawn a new cluster or a new sharded environment, right? It has to be highly available, which means that our shards have to be protected somehow. And this protection mechanism in 21c comes with DataGuard and Golden Gate, which is Golden Gate now is deprecated, and something else in 23c. But while we scale, we also want to have a full ACID compliancy and strict data consistency, but now there is a caveat here. Of course, we cannot be fully consistent across geographical locations because there's something called latency, and you cannot guarantee that system change number on both sides will be the same. But when it comes to sharding locality, then absolutely that's the case. And sharding in an Oracle database, we can actually pretty easy query any type of data like JSON, text, XML, probably in the next release even vector, which I use quite a lot. And of course, from a central point location, me as an application user or as a DBA, I can administer the shards, or I can even query application data from one point or different points. Now, so what are the architecture on a high level, super high level? So sharded database is just a name. It doesn't exist like installation binary. It's a concept, right? So sharded database basically has 4 major components. It's called shard catalog, shard director, and global database service. So sharded database is a standard Oracle 21 database. You download it from the official Metalink URL, and then you install it, right? However, shard is basically an independent Oracle database which hosts only a subset of a particular data, right? Now, in order to have a sharded configuration, you need to have something called shard catalog. So picture this shard catalog as a Arman catalog where you keep all the metadata which is related to your schema, as well as to the metadata about the shard itself. So the topology, for example, which services run on which shard, which objects are created, and things like that. So shard catalog, is a single point of failure, and of course, as such, it has to be protected. There are mechanisms how to do that by using the Oracle MMA architecture with a Golden Gate or a DataGuard or something else. And then shard catalog not only actually acts as a golden copy of our metadata, but also acts as a single point from where we can query the shards. We can see later details what are the best ways, but we can query the whole data if we connect to the sharding catalog database. And then, because we want to have a listeners, right, on each and every shard, Oracle did something called a GSM, or Global Service Manager, or now they renamed it again to something called shard directors. Those are high-performance network listeners, which we configure on a particular port, which we then use with TNS to connect to the shard on particular either shard or a catalog database or a set of shards. And of course, the shard directors are topology aware, which means that they know, based on the sharding key, where to route the data, right? And if you don't specify the sharding key, you can actually land on the catalog, and then the connection gets rerouted, right? And to access the shards, Oracle actually recommends, and it's mandatory, to create a global database service. That's a standard database service, like any other data in classical database. And by default, we have to have one active, and the best practice is that we actually have to deploy one or more passive in case one goes down, etc. This is also aware about the location and the usage. And now, how do we actually manage interface? So imagine we are not talking about 1 or 2 or 3 databases. We are talking about maybe 1,000, because I know that Oracle has few clients which they have over 500 databases. So how do we manage that? So we manage in 2 ways. One is using the command utility called GDSCTL, where we can deploy it externally on our laptop or on our server, so it doesn't have to be part of the sharded database, but of course it has to access the catalog network, or via the Oracle Enterprise Manager Cloud Control. How does this look like visually? So picture this. There are a set of users which, while they connect to a sharded environment, they provide a sharding key called claim country. And of course, this connection goes to connection pool, which is optional, and then goes to the sharding director. Sharding director says, aha, based on my sharding key, which currently sets to Germany, I can access my shard number 1 and where I actually store the location of my German data, right? And this shard is protected by a potentially standby database or active data guard database onto another location or another region. So there is a bunch of documents online what are the best practices to deploy the primary shards, the secondary shards, in which region, which fault tolerant domain. So I'm not going to go to that because there is plenty of knowledge to that. But another use case is like, okay, I don't know the sharding key, right? But I want to query the data. So this guy connects directly to the database, either by connecting to the shard catalog or to the GSM. And GSM will say, okay, you don't have a sharding key. I will read out your connection to the sharding catalog. It's not pictured there on the photo. And then based on that, we're going to do something called cross-shard query. And that's quite expensive, especially if you do, I don't know, count or aggregations. Imagine spawning 500 servers, doing a count, and then aggregating the data back. You don't want to do that. Now, what are the sharding database schema objects, right? So again, it has to start with the table. And before we actually start with the table, Oracle invented something called sharded table family, right? So sharded table families are nothing but the normal Oracle tables, which are sharded the same way. Sharded in the sense that they share the same sharding key. And in order for you actually to create a sharded table or sharded table family, you need to have one root table which is parent to itself, so it doesn't have any children, right? And we're going to see on the next slide is that when we design our schema, we have to cascade this sharding key onto our children or make it part of the composite key if we want to use sharding, right? And very important, there can be only one root table per table family. And we'll see later why this is the case. Now, sharding is based on partitioning. Partitioning, which means that each partition will go to its own dedicated table space, right? So now you might say, okay, well, if I have hundreds of partitions, do I need to create hundreds of table spaces? Yes, but to automate this, there is a new command called tablespace sets, where basically if you create a particular tablespace set, and in the backend, Oracle will actually create X amount of table spaces, and this number is directly proportional to the number of chunks into your database, right? So in this case, it's 120, and the default per database is 120. So what's chunk, right? So now that we have another new element into the picture. So chunk is actually a collection of corresponding partition from same table families. And why this is important? Because this is the single unit of replication that Oracle is doing on the backend, which means that we can have a table family called, I don't know, table family invoices with a bunch of parent-child referential integrity columns stored on one particular tablespace set. And we can have another table family called, let's say, orders stored on another tablespace group, right? But if they share elements between them, then if we want to replicate them and if we want to have a consistency between them, then we have to store them physically, like on the machine itself, in a separate in the same chunk. And that's why chunks are invented. And if you don't specify when you create the database, or when you create a sharded database, by default is 120, right? So if you do a couple of counts from the table spaces, you will see like per each table you have 120, right? That's tablespace sets. Now, besides sharded tables, which are going to be propagated throughout all the shards, you can have something called duplicated tables. And those duplicated tables are nothing but materialized views, which are used to copy the same amount of data across all the shards, which means that lookup tables like vehicle registration numbers, or I don't know, states, or not flight numbers, but let's say airline numbers. This is a perfect use case if you want to have lookup tables, and you need the data throughout the whole shards, right? That's duplicated tables, and it's internally works with materialized views, right? I'm not going to go to that because there is a huge story about that, but nevertheless. And then inside your schema objects, you can have, of course, roles, views, stored procedures, packages, context tests, table spaces, directories, and pretty much everything, even sequences, right? So moving forward, how does this actually sharded table family looks like? For example, up on the photo, on the diagram, we have a sharded table family called claims, and it's been partitioned by consistent hash. That's the syntax if you want to partition it by by something. Of course, we're going to touch base on that a bit later in the slides. And in this case, my claim ID is my partition key, sorry, my sharding key. And all this is being stored onto something called tablespace set TS1. And then throughout my ER model, which is of course only for illustration purposes, this is not correct. There can be many-to-many relations, of course. This was the comment from one of my colleagues who actually reviewed the presentation. You can create another table, and then you have to specify in the syntax like parent table claims, so the sharding can know which is the parent table. And then you have to specify the partition by consistent hash, again, the claim ID. You can specify another key, but the sharding key also has to come always from the parent as a one-to-one or as a composite, right? And same with passengers. And in the diagram below, it's another sharded table set, family, but this time we have table set 2. And if you try to store this table on the tablespace set 1, you get ORA error going to say you cannot store the table because the sharding key is different than this one, right?
And the databases still exist for which you can create the shard.
One again, please.
The database, for instance, you have 3 Oracle databases,
okay.
You want to create a shard.
Okay.
This exists before.
It has to. But if you have an existing configuration with, let's say, 3 shards, and you're running a 4th one, then Oracle will automatically play the DDLs on the next one.
Okay.
So you don't have to do it again on every shard.
And where do you put the access data to access the database into?
No, actually you store it on the catalog, because catalog holds the golden copy of the metadata of all the sharded objects, right?
Okay.
So if you create a new shard, for whatever reason you want to, because Oracle allows to actually split the chunk, move the chunk, copy the chunk to different locations. If you actually decide for performance reasons, whatever reasons, reporting, you want another shard elsewhere, you don't have to run thousands of DDLs again to prepare the data. You just say add shard, and then Oracle will say, okay, this is empty. I will go to the playlist and create all the table spaces. And if it fails, then you can also fix manually that DDL statement on the new sharded environment. And you can mark this DDL as skipped into the catalog database, something which I did when I actually installed the Apex and ORDS on my setup, right? Now, what are the sharding methods, right? So there are 3 sharding methods. One is called system sharding, one is user-defined, and one is composite, right? And in most of the cases, we are going to be always at the composite sharding. Why is that? Because in system sharding, we have no control of where the data is. So system sharding is using something called consistent hash to partition the data, right? So we can have 5 shards, and in a consistent hash fashion, we're going to land into shard 1 and 2 and 3, right? So there is no geographical distribution of the data. You cannot specify I want German data to go to tablespace 1 or to 3 or 5. No, it's only for scaling out writes and scaling out reads, if you will, right? User-defined is basically where you can define which data on a partition value goes to which particular table space, right? But in most of the cases, you want to do also a user-defined partition and system-managed partitions, right? And that's composite. So it's not sub-partition, but it's a partitioning concept. And in all cases, you can even further down some partition by all known sub-partitioning methods to date with the Oracle database. So it's super, super powerful. How does this look like? For example, sharding example for system manage. First, you log into GDSCTL and you say, okay, create or add shard space called shard space Aura. Then you can attach a particular shard, like in this case, shard 1 is the sharded database name, to a particular shard space. And then you create a tablespace set TS1 in this particular tablespace. And what this guy will actually do, pay attention if you want to play on your own environment, choose the data file size to be something small, because remember, each tablespace will have the same initial size. And if you have 120 chunks, you're going to have 120 tablespaces the size of 10 megabytes. In my case, it was 1 gig, and I was kind of, okay, why my disk space is going so full? I haven't had any data, so this was the reason. So you can override this with a template. And then once you do that, you actually create a table. You say partition by consistent cache on this table space, and you're done. And this goes automatically throughout the 1, 2, 3, 4, 5 shards, if you will, right? So user manage, it's a bit different. Then you can create, let's say, 3 different shard spaces. Like in this case, we have shard space Germany, shard space Austria, shard space Switzerland. And then we, of course, connect shard to a particular shard space. And then we create a table space in that particular shard space. And then when we create the partition by list, we can specify which partition goes to which table space. And this is how you actually achieve geolocality, right? Because shard 1 can be in Frankfurt, and shard 3 can be in Zurich, for example. Now, Composite is the same, just that you're doing the same amount of configuration like the user, but this time you can say partition by set list, which particular column you want to shard, and then additional partition consistent by hash, so it's not some partitioning. And furthermore, if you want, you can say subpartition by something else, right? So this is not composite partitioning. This is, something new syntax, right? Now, we have sharded data. We've loaded the data. By the way, the sharded directors and the libraries around sharded directors are optimized for a huge amount of, or a burst amount of data, including IoT. So I spoke with a couple of developers from SF, and basically they put a lot of time and effort how to make the ingestion towards the sharded, let's say, entry point to our database fast enough, right? So, and needless to say, all the Oracle built-in tools like DataPump, RMAN, and EXPDP and PDP are shard aware. So, which means if you are loading data via SQL Loader or DataPump or doing RMAN, they are shard aware. Coming back to querying the data. So, how do you query the data? So, there are two ways. First, it's direct routing, which is the preferred way. We want that, which means that our application needs to have a sharding key. And based on the sharding key, we want to avoid this extra hop of connecting to the GSM or to the catalog database and to go to the shard. We want to go directly to the shard, and that's preferred way, right? But sometimes it's not the case. We have legacy application. We cannot modify them, right? They don't use Java. They don't use Python. So they go via something called proxy routing. Well, proxy routing is when you don't provide the sharding key. In this case, you connect to the catalog database. You can fully write the same query like select star from whatever table where predicate equals something. And then based on that, the catalog database will determine whether to which shard to go into all the shards or whatever. Now, picture situation, for example, very interesting. Let's say you want to do a count of all your data, right, across all the shards. You connect to the catalog, and you say select count star from very big table, right? So what shard catalog will do is going to do something called query coordinator, which means it's going to fire parallel XY queries to all your shards, get the results, and rewrite the query to say sum of of your query, because you want to get a count as a number and not count per each and every shard. You don't want to do the data, right? And that Oracle doing quite nice actually features there. I haven't tested, let's say, to that extent about query rewrite, because I know from experience query rewrite can be tricky when it comes to results and 7445 errors. But now this is completely, let's say, new backend on a database, so it should working. And there are a couple of interesting views if you want to actually troubleshoot how your query is working. One of them is $shard SQL or $shard SQL. And basically you can see which SQL, which is the SQL ID, goes to which shard. And
yeah. Have you ever seen how the explain plan or something looks behind the scene for that?
Yeah, I can show you.
Now, how would it be like if you are using a DB link in your query, the optimizer doesn't know what's behind that?
No, it knows. I'll come to that.
When you use a shard, is it a similar behavior, or how does the optimizer behave?
It's similar behavior, but now, for example, if you do a select over a DB link, that's a PC2Pen intersection, right? So it's a two-phase commit. I think they got rid of that. They're pushing the predicates. So if you write any hint or any predicate into your query, it's going to get pushed to the shards. How accurately this works, I don't know, because I haven't tested it to the latest details. But if you use the DBMS explain plan, basically works the same way like so far all the queries. And you can see, aha, there is a query. This is the shard where it has to go. This is the DB link which is being used. And you can actually even see which chunk is being used. And also, if you actually check, let's say, the GDSCTL, if you type routing, then you can see, aha, I have 5 databases, and then chunk number 1 to 100 goes to first route and second and third. So you can actually see through which link goes and which predicates are being pushed. So you get all the hints like plus advanced if you want to get all the dump from the optimizer performance hints inside your output from DBMS output. It works one-to-one like everything else.
And also, does it have also concept like the partition pruning so that you do not hit all the shards always, like I do select star or something and put the clause? Does it prune the shards as well?
Yes, it does. Exactly the same behavior like partitioning plus the shard. So if you specify and that's a very, very good point, by the way, because there are multiple techniques which I'm not showing now because there is no time about how to collect statistics from the shards and to import them back to the catalog. So there is another initialization parameter which is new, which you set on the catalog database, so that once you collect statistics on the shards, it gets imported to the catalog database. And based on that, the query coordinator knows what is the cardinality and selectivity of each and every table on your sharded tables, and then according to that, it will create a plan and push it down to the shards, right? And yeah, that's about the $V sharding SQL. And there is another very interesting, let's say, parameter which is called multi-shard query data consistency, which by default is set to strong. This means that if you protect your shards with the data guard, and you should protect the shards with the data guard and preferably with data guard. If, let's say, you are doing some kind of reporting and you don't care about so much consistent data, then you can relax the acidity of that results by setting some parameters like shard local, which means you're going to get the most local SCN out of that shard. Or even further, if you type delay standby by allowed, you'll get the data from the standby instance rather than the actual shard itself if you're doing, let's say, heavy writes in that particular time, right? Now, here are some examples like, okay, how does the TNS entry, let's say, looks like if you provide a sharding key, like with the direct routing. And down below, it's actually a code shipped from a Python CX Oracle driver, where we can actually specify the key. And when we actually open the connection, we provide the sharding key. When it comes to driver support, Oracle also had a lot of support for Java, of course, natively, for sharding, for CX Oracle, which means Python. Not, of course, with their own internal tools. Node.js is also there, Rust is there, C++ is there, right? And then on the right side is basically a proxy routing, which means plain vanilla, you just connect to the service name. In this case, it's called GDS $catalog. And then based on the query there, the catalog, you actually say, okay, you have to go to shard A or B, or you have to go do a cross-sharding query because you want to get the same data, right? Something which you have to do it sometimes. And now there is something called undocumented feature or parameter, which it's inside the Oracle documentation, like in one tiny little page, and I got there by mistake by testing actually JSON and Soda. And this is like, imagine you have 100 databases and you're creating your objects, right? But sometimes you want to, let's say, execute a particular procedure only on a particular shard, like not everywhere, or only on a standby instance. And you do that using something called XX shard PL SQL, which is basically inside your C schema. And by something called whitelist bit, which is on the end, you actually specify the values where this DDL or where this procedure should run, whether on the catalog only, on the shards, or on the standby instances, or whether this particular SQL gets locked onto the catalog database. Locked in a sense that you can see it or you can query the metadata in case a new shard comes in and actually you can replay the same feature. Of course, I didn't come with this number. This was a courtesy of Oracle, and I asked them, and they said, yeah, you can publish them, but with a disclaimer that until there is an official documentation, you don't actually use it with caution, right? And that's basically you need this if you want to load a JSON document into a sharded collection via the Soda, right? So you cannot do that without this. Now, how can we test sharding? Well, at the moment, there are not so many options. One is actually do it yourself on a VM or a bare metal, and it's quite challenging. Second option is to go to the OCI marketplace, and there is actually a template there where you can test Oracle sharding, but it's only 19c. And in order to test this, you actually have to increase your account limits of 256 gigabytes per VM, and you need at least 5 machines, so you need at least 1 terabyte of space, but you don't want to test 19, it's old. Then if you want to actually learn a bit more about sharding, you can go with the Live Labs, and there are like 6 or 7 nice trainings about what sharding means, sharding for DBA, sharding for application administrators. And then the best part is about testing. If you go to actually the official GitHub repo of Oracle, there are 3 possibilities to test. One is using the Terraform. So if you are keen with Terraform, or if you have, let's say, automation guys in your team, you can use the Terraform scripts and you can bootstrap new machines, and all these scripts are actually going to configure the sharding for you. If you do Kubernetes, it's the same. I opted for the Docker version because I have hands-on experience with Docker, but it took me quite some time to actually set it up because if you follow the official documentation how to build the images, they're failing on 3-4 different errors. And there are a couple of workarounds which I actually documented them so you don't have to go through them. And if anybody of you wants to actually test sharding, let me know. I literally need 24 minutes to bootstrap the entire cluster, and out of which we're going to have 22 minutes coffee. So it's just running one command and then waiting 24 minutes to bootstrap the cluster. Over the last 1 month, I think I did it more than 500 times, seriously, like from my laptop. So 24 minutes we wait on a, and this will cost you 67 euros per month because this is how much I'm paying for my single instance OCI VM with 4 cores and 24 gigs of memory and 150 gigs of space. 67 euros per month flat, in case you want. And I can even give you my images so you don't have to build them. So we just copy them with STP and then you say start up and you're there. But very soon there will be something on the OCI cloud announced on Oracle Open World, and you will see it on the next slide. What's that? So now, talking about new features of 23c, I am basically super excited that finally rough replication is coming to Oracle, because ever since I started with the Oracle like 2005 professionally, back then Cassandra was in a beta version, and it was fascinating, you know, to spin up a new cluster of hundreds of databases with a CLI, and we didn't have that. We had Golden Gate, we had everything else. And throughout the years, another players emerged, like, you know, Postgres with Citrus replication, or now Gigabyte, or Google Spanner, or MongoDB, right? But somehow Oracle was always lacking the sharding feature, and although it was present first in Oracle 12c, it was kind of not working, put it this way, like table specification with Golden Gate. With 21c, it's very stable, it's working, there are lots of customers using it, but with 23c, believe me, I think that it's the biggest development effort that Oracle did after Exadata. So it's the feature that is gonna sell Oracle in the next 3 to 5 years, because I've read somewhere a Gartner report saying that the global distributed database will be the next big thing in the next 3 to 5 years. So there's going to be a huge market share there, and obviously Oracle wants to fight with that. Now, there are 2 main features and actually 1 new product, and one such feature is called rough replication. Second is something called automatic request routing for Java applications. And the OCI, basically, Oracle will announce now in global world that Oracle sharding will no longer be called sharding, it's going to be called globally distributed database. And they are actually creating a new product on their OCI cloud where you can basically log in and create the sharding. You will see the slides there. I actually clicked a couple of times. I got also access to that. Now, so what is actually Raft? So Raft is a consensus algorithm. Consensus means that, okay, it's basically a core or fundamental problem in distributed computing where you're trying to make actually a system to be reliable, but there are so many things that can go wrong, like partition outages, machines are down, and it's kind of a notorious problem. It's an NP-complete problem, right? All the NoSQL databases are relying on not being reliable, right? That's why you have this something called CAP theorem, where you can choose between consistency and availability and partitioning, but you can always choose 2. So basically the same thing here. So there are 2 main, let's say, algorithms like this. It's called Raft and Paxos. They are both the same in terms of performance and stability. Raft is a bit better, and probably that's why most of the big database players are using it, because it allows a little bit more granularity when it comes to controlling who's going to be the leader and follower. And that's actually a big deal, because then you have more administration options for us. It's basically a zero-loss replication protocol, if you will. And it's open source. You can go download and read the white paper, actually quite scientific paper. They even have a visualization how it's working. It's based on something called leader-follower concept, which means that you need to have at least 3 shards in the configuration, so that each of these shards is going to be a leader, and each of these shards is going to have a subset of the data of the other shard. So if one goes down, you still are highly available, and there is 0 data loss among the 2 shards. And of course, what is the best part is that if you add a new shard in the configuration, it gets automatically scaled. So the data gets automatically scaled. And to do that, Oracle went step beyond. You remember we had partitions, table-space sets, chunks. Now they're adding another kind of logical groupation, or let's say namespace. It's called replication unit, where they group down, preferably, there is no documentation on that, particular chunks into one replication unit. So when you bootstrap a new shard, you're going to say, okay, replication unit 1, 2, 3, 4, 5, we'll go to the new shards and voila, do the replication, right? And it's beautiful. And it's so easy that it's only one command. You just say GDS control, move replication unit minus RU, which replication unit number you want, from source database to which database, and then boom, that's it. Or you can even copy if you want to have multiple copies of the same data on another shard. It's that easy, like super simple. Now, what is important now is that if you go back with your mind, let's say on the picture about the shards here, you see these shards don't see each other, right? So it's an isolated database, and shard 1 talks to shard 2 only via active data guard or data guards, and there is replication, right? Whereas in 23c, shards talk to each other, right? That's why you can have, you see, shard number 1, there are 2 leaders, and so the leader 1, 10, and 5, and then the shard 2 basically has follower for 10 and 5. So the data is also copied there. You can also copy it here if you like, or if you in another database, right? So this is how, this is like a mesh network. So the more photos you are, so if I add here another, let's say, a fourth shard, then I need to repoint all the arrows to the old shards mix max, right? So factor of 4, factorial 4, 4 times 3 times 2, right? Now, we spoke about sharding key. Well, in 23c, if you use Java application, that's no longer needed because Oracle did an update of the JDBC drivers. And basically now what they're doing is they're actually scanning for the SQL statements, and based on the bind variables, they're parsing and saying, okay, this bind variable, we can match it with the sharding key. And it's a super cool feature. We just need to enable one sharding connection through. This is kind of minimal to no change of duplications. I wish this comes also to Python and to other drivers, but I think that Oracle goes first with Java because the majority of applications that are going to use this is Boot Spring and Java, preferably. Now, about the globally distributed autonomous database, as I said, it's going to be announced now, I think in 2 weeks' time. The GA should be, or the beta should be completed by December this year. So you can log into the OCI and literally you can say, okay, I want to deploy my shards. And you get a map and you say, okay, I want to go to Europe and USA and India and South Africa. You specify the number of replicas, which means how many leaders and followers you're going to have. Click, next, 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 finish. And I actually spoke with the guy who is doing the backend orchestration of that. I mean, part of the team doing that. And I'm so pleased to know that Oracle is actually investing more efforts into containerizations and Podman and even Kubernetes, because this all runs under Kubernetes, right? Otherwise, there is no way you can automate this, Ansible and Kubernetes. So this is coming. Of course, you can specify it in a table way, but it's coming, right? Now, about the demo. I'm quite fast, but I think we can spend a bit some time about the seal. I can walk you through if you have some time. So what's the demo, right? So as I said, potential client of ours, actually now it's a client of ours, they have some old applications written in the mean stack, and it's a Mongo, and they collect a bunch of airline data and claims, right? And now they want to modernize for whatever reasons, and they want to go with Oracle. Of course, we consulted them with that. And now we need to migrate the data from Mongo database to the Oracle, right? And of course, sharding comes into picture because there are very strict regulations when it comes to flight data, particularly PyPeda in Canada. And before we do that, of course, we need to do some homework, which means we need to do some assessment and planning. We need to see the JSON structure of the MongoDB database and the collections, because in MongoDB, it basically boils down to 2 things: whether you embed the documents or you actually link the documents, right? So this means if you have one huge JSON and sub-JSONs of the data in the same document, where with one I/O you get all the data. Of course, there are pros and cons. You put a pressure on the memory and the I/O and things like that. Or you actually decouple them in collections or simple tables, and then you do a lookups. And the later one is much faster, more performant, but when you do joins and lookups, you actually have to do a lot of I/O and joining on your application side. So this is the first step that we did, and we actually tried to map the MongoDB documents with our potential structure, whether we're going to use SODA or JSON, or whether we're going to use the flat columns, like, for example, for the most commonly used, if you will, tables or columns, we actually opted to have real columns like varchars and text, and rather than one big JSON, and then to index them. And then we did that, and then of course part of the solution was data modeling, which means we have to see, okay, how do we play with the geographical locations of the data, how we do the data modeling, which partitions goes to which particular locations, Canada, South America, South Africa, and things like that. That's done. And then the point was, okay, how do we now extract the data? It's actually simple, because Mongo, it's nothing but a JSON flat data. And there is a tool called MongoDB Export, which comes with Mongo. You dump the data into CSV, and then you can use the SQL loader. So this is wrong. It has to go from here. Or you can do a custom solution, which I can demo it now. Of course, I cannot show you the actual schema because of NDA and stuff. Or we can even use Oracle Golden Gate for big data, and it supports Mongo. And once you do that, or once you do the first time load, then if you need to have a continuous change data capture, sorry, yes.
If you use sharding, must you license already Golden Gate separately?
If you have a license, no. For Golden Gate, no. If you want to use it, then yes.
Okay.
But Oracle is actually deprecating it Golden Gate in 21c. So if your setup is already using it to replicate the data onto the standby shards, then you don't have to pay for anything. But also for the data guard, if you have a license for data guard, you're not paying extra. But if you want, like, you don't use it, you have data guard, and you want to use Golden Gate, then of course you have to license it. And if you want, let's say, continuous data capture and extraction, then of course Golden Gate for big data, and then you have to make sure that you use the filter option, because Golden Gate maybe is not, at least in the version which you can install, it's not shard aware, but with the filtering options, you can actually channelize the data to the appropriate shards, if you will, right? And then, of course, you need to do a lot of application testing. My desire was that because this application is written in MinStack and it's using the Mongo URI connection string, that I was able to actually use the Mongo API. But Mongo API that was announced in 21c and now in 23c, it's not supporting sharded table writes, which means that you can do it for reads, you can connect via the MongoDB, but you cannot you cannot do a write because it will say the collection is in read-only state, right? So I actually raised this question as a feature request for the development team. Probably they're going to do it sometimes in the future. But it's not a big deal because anyhow we need to rewrite the application. So it would be nice to show to the client, you have a Node.js backend, you have a Mongo URI. Look, magic happens. I'm just going to change the URL, and it looks exactly like Mongo, but now it's in Oracle, right? It's super cool. But nevertheless, now what I'm going to show you now is basically I'm going to simulate 100 records or 100 claims into my MongoDB cluster or Atlas cluster, which I have, I think it's in North California or whatever. And I'm going to do that using Python, and PyMongo is the library which we use to access the Mongo. And then I have a shell script which basically runs the one query in Mongo. It's called aggregation, where I'm going to just visually summarize your data, saying like how much is the total claim and how many claims I have per country and what is the sum, so you can actually visually see that the numbers are matching. And then I have another code which says claims migrate, which is going to basically connect to Mongo. It's going to connect to Oracle and then move the data from Mongo to Oracle. It's kind of my version of Golden Gate because I don't want to pay for Golden Gate. We can actually do we can do some checkpointing later on, so we can extract only the delta of these documents and things like that. It's not a big database, but it's a complicated JSON structure, so we have to see how we can do that. And then we can all visualize this by showing you the raw data in MongoDB. So you will see the MongoDB, and I can show you the same data into Oracle Apex visualization, and it's going to be one-to-one match, so I hope. So off we go. So let me see. So currently, you see, I have some 2 more minutes. I'm done in 1:45. So here I'm actually showing the previous execution test. So now I'm going to actually log into the to the database. I'm going to say delete from claims, and I'm deleting, so there is nothing there, right? It's completely nothing. Whereas in the Mongo, this is my production or imaginary production cluster, I have a database called Swiss Oracle User Group, and I have a collection called claims, and inside I have 100 documents. You see here 100 documents, and I have filtered only the one from Germany, right? So they have flight number, flight data, blah, blah, blah. And now I'm going to actually go to my cluster here. Actually, I can go here. No, I won't do this. So I will say claims generate. And basically, this is now going to the MongoDB cluster. It's going to delete all the data. It's going to generate 100 new records randomly because I don't want to fake the result. And then we're going to migrate the same data to Oracle. We show the Apex, and that would be it. It's a bit slow because it's no. And look now, okay, so you see, we have like total amount of 54K, and we have 100 records, and then we see the count per country per claim, right? And now I'm going to say something called claims migrate, right? And now this will actually go to Mongo, fetch records, and then store them in the Oracle database. And now we're going to see them actually here. If I refresh the screen, Slowly they're going to come up, of course. It's not there yet. We are at 60 rows. That's the Mongo to blame, it's not Oracle. Because my Oracle is in Frankfurt and the Mongo production is in California. So it's quite a lot of data. And now, if you actually go to claim summary, you see, okay, 80 more, 20 more. Yeah, here you go. So you see here, claim summary, I have 100 claims. This is the amount, and this is per country, right? And all this is basically identical like the one in Mongo. So if I go here to my queries, and if I run the aggregation pipeline, you will see exactly the same numbers, and it's one-to-one. And with that, I am done with my presentation and open to questions. Thanks a lot to a bunch of people who actually helped me to build this. And given said that, yeah, this was more difficult than I had to convince my wife that I need a new bike in May. So, so Q&A, I'm here for your questions.
One simple question. How easy is the documentation to follow, and how's the support?
Documentation is great, but there is documentation only specifies how you can install the sharding on a bare metal. It doesn't say anything about Docker. There is only one-pager commands, which they don't work. And all the working commands basically are in my slides. And seriously, if you want to do it, just bootstrap a VM on OCI, and it has to be Oracle Linux 7. Thank me later why. I spent 2 weeks in that. I literally can connect using Teams, and I will bootstrap your cluster in 24 minutes.
And support, Oracle support, did you happen to interact?
No, I did not open any tickets. I was just communicating with all the developers, including the team who actually containerizes that. That's Pramad and Pankaj and Jyoti. These guys are actually putting the data in, the libraries into containers. And of course, with Maxim. Maxim is a developer for Soda, and also Richard, so about Mongo. So if you need help with that, of course, feel free to shoot an email. Basically, this is the whole sharding product team. But if you want to play with your environment, please let me know. And seriously, the next 2 weeks, I'm more or less relaxed from work, and I can set up your cluster in no time.
Another question: if you fire a query against Oracle Shard database, do you get the same execution time on all shards?
Not necessarily. That's a good question, depending on statistics. You cannot. So you can. It's at the end, it's a hint, right? So you can hint it, but depending on the actual statistics or whatever Oracle decides CPU to do that, these databases don't see each other, so you can have a different init Ora parameters, right? So basically, even if you force, let's say, more towards index trees other than full table scans, right? And on that particular instance, you have tuned it for whatever reason differently, you'll get different execution plan, right? So it's not. And I forgot one important thing. In the partitioning, you cannot do global indexing because they corrupt the consistency. It's only local. No, local only. Yes.
Because of the sharding key?
Because of the sharding key and the consistency in the replication, right? At least in 21c. I don't have the official documentation of 23c, only the sharding part, but maybe they can change. So technically it's possible, but with disclaimer that you might actually do it. Okay? Thank you.